Hello guys. You see, in this session, we will see another important topic. No, there is mention about this topic in the budget also, latest budget, that is the launch of India Semiconductor Mission. Okay. You see, we had India Semiconductor Mission, 1.0. It was announced in 2021. Now it has been completed, riding on the success of the first mission. Now in the latest budget, the India Semiconductor Mission 2.0 has been announced. Okay, you see, it's a really important topic from the point of view of examination. Always the electronics and the electronics components manufacturing, all these things are, you know, are there in the news, and they are critical to India according to the changing global scenario. So in this context, we will try and understand the details that are there with respect to the India Semiconductor Mission. Okay, so some key we will start with the key takeaways that were there in the budget. The Union Budget 2026-27 allocates 1,000 crore rupees for India Semiconductor Mission 2.0. Okay, then as in December 2025, 10 ISM projects worth of 1.60 lakh crore have been approved by the government in 6 different states. We will see the list of 10 projects that are approved also a little bit later. Okay. And after that, India semiconductor market is projected to reach 100 to 110 billion dollars in the coming 5 years by 2030. Okay, these are some of the key takeaways. If you see some introduction to the semiconductors and why they are important, etc. Like I've told, the present budget has announced or it marked a decisive moment for India's technology ambitions with the announcement of this particular mission, ISM 2.0. Okay, you see, this new phase signals a clear policy push to deepen Indian or domestic semiconductor capabilities, including design, manufacturing, testing, packaging, everything. You see, one thing you have to understand that we are I would say we are very backward, or we have missed the bus with respect to semiconductors. Okay, the facility is little bit, you go little bit few years back, it's almost absent in our country. Even design, manufacturing, testing, packaging, these things are absent in our country. Of course, some design is there, but Indians, they themselves are not, I mean, they were not doing it on their own. They were designing for some other companies, foreign companies. So you can say indirectly, this design capabilities were there. I mean, Indians were doing it, but it's for some other companies, foreign companies. So that issue is there. So in this scenario, the ISM 2.0 will focus on producing semiconductor equipment and materials in India, associated or required materials in India, designing full stack Indian semiconductor intellectual property, and fortifying both domestic and global supply chains. You see, if you see the semiconductor supply chains now, they are just concentrated in few countries like Taiwan, Japan, South Korea, China, USA. Beyond this, no other country has real participation in the supply chains. So by India becoming a partner or part of this global supply chain, it wants to strengthen that global supply chain. Okay. So 1,000 crore rupees have been allocated in this budget for ISM Mission 2.0. Okay. Right. You see, semiconductors are the backbone of modern electronics. Like you know very well, everything practically we switch on something, switch off something. Everything has semiconductor in it. Okay, so that comprises of electronics, powering computers, mobile devices, telecommunications, automobiles, defense systems, and even AI has semiconductors. Okay, of course, India has made some progress consolidating earlier investments into a full stack value chain of its semiconductor ecosystem under the earlier mission, that is ISM 1.0. Okay, so further expanding the design capabilities and advancing the fabrication, assembly and testing, that India is trying to develop these capabilities furthermore in the present mission. Okay, so this momentum reflects the broader vision of Atmanirbhar Bharat, that is self-reliance, especially with respect to critical aspects, and India's transition from policy formulation to production readiness. Okay, so in this way, this particular mission wants to consolidate India's position as a reliable and competitive participant in the global semiconductor network. Okay, so little bit data we will see. If you see the size of Indian semiconductor market in 2023, it was $38 billion. By 24-25, it has risen to 45 to 50 billion. In the next 5 years, by 2030, it is expected that it will reach 100 to 110 billion dollars. Okay, right. You see, in this way, India is steadily emerging as a global semiconductor hub. We can say that. Okay, there are large scale investments, expanding manufacturing capacity. It is also called as fabrication, and platforms such as Semicon India 2025. They reflect the growing global confidence in India's semiconductor journey. Excuse me. Right. Like I told, India is expected to, or the market of semiconductors in India is expected to reach 100 to 110 billion dollars by 2030. This expansion is anchored by the national vision of Make in India and Make for the World. Okay. You see, the foundation for this growth has been laid with the approval of ISM 1.0, which was actually started in 2021. Okay, this earlier mission, it was supported by an incentive framework of 76,000 crore rupees, offering fiscal support up to 50% for silicon fabs, compound semiconductor facilities, assembly and testing units, and chip design. Okay, if you see the data as of December 2025, 10 projects with a total investment of 1.6 lakh crores have been approved by the government across 6 states. Okay, these include silicon fabrication units, silicon carbide fabs, advanced and memory packaging facilities, and specialized assembly and testing infrastructure. Excuse me. You see some important data is there. That is, by 2029, India is expected to achieve capability to design and manufacture chips that are required for nearly 70 to 75% of domestic applications. So we will be close to self-reliance with respect to semiconductors by the year of 2029. Okay, so advancing on this position, the next phase under the Semicon 2.0 will be focusing on advanced manufacturing with a clearly defined roadmap to achieve 3 nanometer and 2 nanometer technology nodes. You see, one thing you have to remember, the semiconductors that we are producing now they are more than 20 nanometer. Okay, we are focusing on 24 nanometer chips, 40 nanometer chips, etc., etc. Rightly, we have done that. First, we have to learn it, how to fabricate, manufacture, design these semiconductors. Once we learn the less difficult ones, then always we can move to advanced level, that is fabricating the 3 nanometer, 2 nanometer, and even 4 nanometer and 8 nanometer nanometer chips, right? So by 2035, India aims to be among the top semiconductor nations globally. This is our target, right? So the list of 10 semiconductor manufacturing projects, if you see, Micron Technology Okay, then Tata Electronics Private Limited. Two projects have been actually of Tata's. Then CG Power and Industrial Solutions Limited, Keynes Technology India Limited. Okay, Vamasundari Investments Private Limited. Then 3D Glass Solutions Limited, 6M Private Limited, Continental Device India Private Limited, Advanced System in Packaging Technologies Private Limited. Okay, these are the 10 projects that have been given approval to produce, design, manufacture these semiconductors. Okay, so all these facilities are expected to meet the growing chip requirements of key sectors such as consumer appliances, industrial electronics, automobiles, telecommunications, aerospace, and power electronics. Okay, notably, if you see, several approved proposals are leveraging the indigenous technologies, means the technologies that are already there in our country, instead of depending on the technologies that are coming from outside of the country. Okay, for doing all these things, for doing assembly, testing, and packaging of semiconductor chips. Like I told, we have the designers, but they are doing it for the foreign companies, not for Indian companies. Okay, so we are doing it, we are utilizing indigenous technology for assembly, testing, and packaging of semiconductor chips. Design, we are not yet there. Okay, this shift reflects the move towards a deeper technological capability and a reduced dependence on external systems, strengthening our position in global semiconductor value chain. Okay, then within the integrated semiconductor mission, there are sub schemes. What are the sub schemes? The sub schemes are semiconductor Fabs scheme. It provides up to 50% of fiscal support for setting up of semiconductor wafer fabrication units covering advanced and mature technology nodes. Then display Fabs scheme is there. It also offers up to 50% of financial support to establishing AMOLED and LCD display fabrication units in our country. Then third component, subcomponent is there, that is compound semiconductors and ATMP or OSAT scheme. This scheme also supports compound semiconductor and chip assembly, testing, and packaging units with up to 50% of capital assistance. Then fourth component is there, that is design linked incentive scheme. Sorry, just like the PLI scheme, production linked incentive scheme, this is design linked incentive scheme with an outlay of 10,000 crore rupees. It supports chip design startups and MSMEs through R&D support and incentives up to 15 crore rupees per company. These are the sub-components and these are the supports given for these sub-components within the ISM scheme. Okay. If you see the anticipated impact of this semiconductor program in the year of 2026 and 27, okay, you see our semiconductor program has been recalibrated in response to intensifying global competition. You see already few countries have concentrated the value chain. Further, they are intensifying the competition. They are just trying to confine the value chain to themselves. Okay, and that is further concentration of advanced chip technologies among a limited number of players, like the names I have already taken: South Korea, Japan, Taiwan, China, and United States of America. So in response to this, our modified program that focuses on strengthening financial support for investments across semiconductor manufacturing, display fabrication, and a design ecosystem. Okay, for the years 2026-27, if you see this modified program for a development of semiconductor and a display manufacturing ecosystem in India, it has a total financial outlay of 8,000 crore rupees. Okay, and then sub-components we have seen. Modified sub-components are there. We will see the sub-components. Modified scheme for semiconductor fabs. Okay, investment during the year 2026-27 will be 4,000 crore rupees, and expected generation of employment will be 1,500 persons. Second one, modified scheme for compound semiconductors conductors, silicon photonics, sensors, discrete fabs and assembly, testing, marketing and packaging, ATMP, or outsourced semiconductor assembly and test, OSAT. Okay. So investment is expected to be 11,000 crore rupees. Employment generated will be 3,000. Okay, 3,000 persons. Then third one, design linked incentive scheme. If you see the expected investment is 10 crore rupees, and number of people that are going to be employed is 2,000. Okay, right. You see few aspects, very important aspects we will focus on, major important themes we will focus on, and see why we have to focus on semiconductor industry, how it is important, etc. So why the India Semiconductor Mission matters? If we examine that, semiconductors have critical to have become critical to the functioning of modern economies. We cannot imagine the modern economies without semiconductors. Okay, though it's rarely visible in everyday life, the microprocessors, alternately they are called as semiconductors also, we call them as ICs, integrated chips, etc. Multiple names we use. The microprocessors, they quietly power systems that keep the societies running. Okay, as highlighted in the economic survey 25-26 also, the semiconductors or microprocessors, they form the backbone of energy networks, financial markets, and telecommunications. Okay, they also enable manufacturing units, hospitals, transport systems, and satellites. Okay, for this reason, a reliable supply of semiconductors is very, very essential. Okay, you see recent global disruptions, they have further underscored the dependence on semiconductors for the rest of the world. For example, you have seen COVID-19 pandemic. It exposed the serious weaknesses in semiconductor supply chains, with the shortages affecting more than 169 industries worldwide. Okay, you see, these shocks revealed the risks of relying on a narrow set of suppliers. Like I told, the semiconductor industry is now dominated by few countries, including Taiwan, South Korea, Japan, China, and United States. Okay, that too, Taiwan alone produces over 60% of the world's semiconductors, and nearly 90% of the most advanced chips are just produced in Taiwan. Okay, leaving the supply chains vulnerable to external shocks and geopolitical tensions. Okay, you might think that, okay, it's Taiwan, right? It's not China. Okay, so what is the problem? But the problem is, you see very well, China has ambitions over Taiwan. We know very well the geopolitical context. So we never know, China might, attack Taiwan and got control of Taiwan. Then what happens? Okay, that's why many countries are looking beyond China. Actually, Taiwan. Actually, the policy is China plus one strategy now. So for every supply chain, they are looking beyond China, along with China. Okay, if China is there, along with China, one more country shall also be there, which shall be supplying the critical components that are required across the across the economy. So India wants to become this plus one country, of course, for the semiconductors, because we are discussing here the semiconductors, but in many other manufacturing areas, India wants to become a reliable partner in this global value chain, providing an alternative to China. Okay, so in this response to in response, because supply chain of semiconductors is concentrated in few countries, major economies are recalibrating their strategies. So India is also doing that. For example, the United States, European Union, Japan, and South Korea, they have launched national initiatives to strengthen domestic chip manufacturing and diversify supply chains. Okay, in this scenario, India is positioning itself within this global shift as a trusted and a reliable partner, the countries which can rely happily on India for the supply of the semiconductors. Okay. You see rightly the India Semiconductor Mission responds directly to this movement. Okay. Right. You see, at the core of this strategy lies a strong focus on semiconductor design and talent development, which together form the foundation for technological self-reliance of our country. Okay. Then, if you see the measures that are strengthening India's semiconductor design ecosystem, if you see them, since its launch in December 2021, the design linked incentive scheme, it has played an important role in transitioning from capacity creation to technological depth in our country. Okay, the scheme focuses on nurturing domestic innovation, supporting early stage companies, and creating the foundation for a vibrant, fabless ecosystem. Okay, it has also helped bridge the gap between academic research and industry application. Okay, these are the contributions of semiconductor design ecosystem. Okay. Then if you see the key achievements under the design linked incentive scheme, as on January 2026, the program currently supports 24 semiconductor design startups across the country. The startups under the scheme have attracted nearly 430 crore in venture capital funding. Then the Advanced Electronic Design Automation EDA, the National Chip Design Platform, it has enabled access to high-end design tools with approximately 2.25 crore tool hours recorded. Then apart from that, 67,000 students, over 1,000 startup and over 1,000 startup engineers, they are actively using these tools for chip design and development. Okay. In academia, 122 designs have been taped out with 56 chips fabricated at 180 nanometer at the semiconductor laboratory in Mohali. So in this way, several other achievements are there, which are the fruits of the program that we have started. Okay. Then we will come to the next segment, that is advancing indigenous microprocessors and core semiconductor technologies. Okay. You see, already we have seen microprocessors. They form the foundational layer of modern digital infrastructure, powering devices and systems across telecommunications, mobility, healthcare, industry, defense, and space. Okay. So recognizing the role of or strategic importance of these microprocessors, India has made focused investments to build sovereign capabilities in advanced processor design as a core pillar of semiconductor self-reliance. Okay. You see, some semiconductors have already been built our country. One such great example is Dhruv 64, which is a fully indigenous 64-bit microprocessor, which is actually delivered by CDAC. Okay, which is developed by CDAC under the microprocessor development program. Okay, you see, its development provides India with a secure homegrown processor platform, reducing the long-term dependence on imported chips, particularly significant given India consumes nearly 20% of the global microprocessor output. Okay, so taking or riding on this success of Dhruv 64, they built a portfolio of indigenous processors, including Shakti, Ajit, Vikram, and Tejas. Okay, collectively forming the foundation of Indian processor ecosystem. Okay, all these are developed under the Digital India RISC-V or DIRV program. These processors leverage on open source RISC-V, technology or platform. Okay, RISC-V architecture, eliminating the license cost and enabling collective innovation across academia, startups, and the industry. Okay, in this way, the rollout of Dhruv 64 alongside the ongoing development of Dhanush and Dhanush Plus system. Okay, these chip variants, they strengthen India's R&D ecosystem, accelerates product prototyping, and expands opportunities for domestic design talent. Okay. You see, together all these initiatives, they position microprocessors not merely as components, but as strategic enablers of India's digital sovereignty, supporting innovation, securing critical infrastructure, and anchoring the country's long-term ambitions in the global semiconductor value chain. Okay. Then if you see the development of semiconductor talent pool, that is developing the human resource in the semiconductor arena or semiconductor segment, a strong semiconductor ecosystem depends as much on people as on infrastructure. So along with the physical infrastructure, human resource or human infrastructure is also required. So rightly, India has therefore adopted a comprehensive approach to build a large, skilled and industry ready talent base across design, manufacturing and advanced packaging. Okay. So several initiatives are there to develop the manpower or human resources. First one is Chips to Startup program. This program enables access to the latest electronic design automation tools across 397 universities and startups. Okay, using these tools, chip designers from more than 46 universities, they have designed and fabricated 56 chips at the semiconductor laboratory in Mohali. Second program is academic programs under the All India Council for Technical Education, AICTE. So specialized academic programs have been introduced to integrate semiconductor education into the mainstream engineering. Okay, so some courses have been started under AICTE. Then Smart Lab at NIE-LIT Calicut. So this initiative targets 1 lakh engineers across the country with more than 62,000 engineers already trained, significantly strengthening the national talent pool. Okay. Then another important initiative is industry partnership with the LAM research. Okay. The focus here is on building specialized skills for ATMP. Okay, that is assembly, testing, manufacturing and packaging and advanced packing facilities. Okay. Then Future Skills Prime program. This program is a joint initiative of MeitY and NASSCOM. This is designed to position India as a global digital talent hub. It focuses on skilling, reskilling, and upskilling in emerging technologies, including the semiconductors. You see, all these initiatives have been taken to strengthen the human resource in the semiconductor segment of our country. Okay, so this is what you have to know all about the India Semiconductor Mission. We have gone beyond and we have seen many more aspects that are related to semiconductors in our country. Okay, so if you want to, the Honorable Minister, Central Minister Ashwini Vaishnav, okay, he has also given elaborate interviews, about the semiconductors, their importance, and what India is doing with respect to semiconductors, etc. There are videos available in the, in social media and other online platforms. Addition to this knowledge that we have gotten here, you can watch the knowledge and always you can explore more literature. And the point I want to make here is you have a complete understanding of this segment, semiconductor segment, because definitely I'm expecting a question, not just in the prelims, in the mains also. Always we can expect questions because this is a critical area, complex area. So always UPSC keeps on asking questions from this segment. So that's why you make sure that you get the required information, required information from all these sources that I have mentioned. Okay, so this is it for today. See you next time. Until then, you have a very good time.